This program is going to be on Boolean operators and relational operators and all kinds of fun stuff. So before we begin, I'd like to bring up a Word document that shows you what we're going to deal with. We've got logical operators that will be used with Boolean statements. We're going to use the double ampersand for AND, the double pipe, which if you don't know where it is, will help you find it, for OR, and the exclamation mark or bang for not. I am going to assume that from math you are familiar with greater than, less than, greater than or equal to, less than or equal to. We've talked a little bit about equal for the is equal to, and then from above the not and the equal sign for not equal to. So we'll be using all of those, and we'll be putting them into an expression that looks like this: if something and something, and if all of that. Now we're going to look at something called a truth table. We're going to say that capital A is greater than B, and B is equal to C is greater than D. So now I've got, if A and B are both true, for an AND expression, our expression is A and B. If both of them are true, the expression is true. For everything else, the expression is false. So for a AND expression, both items have to be true, otherwise it's false. In an OR situation, I have got the same A and B. This time I have A or B. If they're both true, it's true. If one of them is true, so I can have false true, that will be true. True false, that will be true. But false false is false. So now we're going to have to look at how do I code all this and what do I do with it. So we're going to start off and we're going to do this with mathematical expressions. And I've got over here, as I move down, we can always look over here for what A, B, C, and D are. So I've got int A equals 1, int B equals 2, int C equals 3, and int D equals 4. And for a simple if-else statement, if A is if A is less than B, if A is less than B, I print out A is less than B if this statement is true. If it's false, it's going to say A is not less than B. Well, obviously in this case 1 is less than 2, so this would print out A is less than B. What's going to get to be fun is when I combine some of these together. So what follows contains an and statement. Both statements must be true if this is going to return true. So we have A is less than B and C is less than D. Well, in that case, 1 is less than 2, 3 is less than 4. So if I compile and run this, let's scoot this up. It said both statements are true. All right, and the first time I had A is less than B from this, and now both statements are true. So that was wonderful. Now, again, I have a single AND statement, and the statement must be true. Both must be true, or if one of them is false, it will return false. So now I have A is less than B and C is greater than D. Well, C is not greater than D, so one of them, at least one of them, is false. So because this was false, it's going to return false. And I could reverse that. I could have A is greater than B, or and then I'd have C is less than D. So now this is false, this is true, and I still get at least one of the statements is false. So it doesn't matter which way you run that. I now have an AND statement where only one of the statements needs to be true. So A is less than B, that's true. This is also true. So both of them being true is wonderful. Down here, A is less than B, C is greater than D. Well, this is false, but this one is true. So at least one of them is true. And finally we get A is greater than B, C is greater than D. They're both false. So it's going to return both statements are false. And we have those again. Now we're going to get into the fun part of this. I have now said E is going to be A over B. This should return 0 because 1 divided by 2 is 0.5, but it truncates, so this is going to be 0. 2 divided by 1, surprise, surprise, is going to return 2. Then 4 divided by 2 will also return 2. D, which is, or excuse me, H, which is 4 divided by 3, also returns 1 because of integer math. So these are things we've got to look out for. And now we're going to print out the value of E is 0, the value of F is 2, the value of G is 2, and the value of H is 1. So we've printed those out just so we've got them. And one of the important things we have to look at is something called short circuit analysis. And this is going to be in the AND statement. If the first one is false, you don't have to evaluate the second expression. Well, why would you care? Well, let's look at this. If, let's see, what do we have here? E is greater than F. Well, is E is 0 greater than 2? No, that's false. But what is A divided by E? Well, A was 1, but E is 0. All right. What would happen if I didn't have this false? We're going to see in a moment. It's going to print out life. Yeah, all right. Because this statement is false, this returns false, and it does the else. So let us convince ourselves of that. Compile and run. So it prints out life is not good, which is this, because one of these statements is false. Now let me make it true. Now we know that E0 is less than 2, so that's going to be true. And compile. And notice it compiles fine. Wow. And I get a divide by 0 error. That's because since this is true, I now have to evaluate the second expression. And the second expression has 1 divided by 0. And I get a divide by 0 error. But when this is false, okay. So we got the divide by 0 error if this statement was true. But when this statement is false, and we make sure it's saved and compiled and run, I don't get a divide by 0 error, but it prints out that the statement, the overall statement, is false. Now, in a short circuit with an OR statement, if the first statement is true, then you don't have to evaluate the second statement. So E is less than F. That is true. So we come down here and it says life is good because the first one is, this should now be true. Okay, with the OR statement, if the first one is true, I don't have to evaluate the second one, so it does print out life is good because the first one is true. If I make the first one false, I suspect you now realize that this is going to throw a divide by zero error. There's my divide by zero error. This was false, and with an OR statement, if the first one is false, I have to go ahead and evaluate the second one to see if it is true. So we want to leave that, but we'll put this back the way it was. And since this first one is true, everything works fine. In the AND statement, we short circuit if the first one is false. In the OR statement, we short circuit if the first one is true. Now we're going to have H equal 1 or H equal A. So remember H was 4/3, but this is still going to return true because in integer math, 4 divided by 3 is 1. So we'll compile and run. And it said, life is strange, 4/3 is not 1. Oh well. So it printed this statement because of integer math. So now we're going to get back into integer math, and we're going to get into the short circuit, which is going to provide us opportunities to get caught. And we have to look at what are we evaluating and which half of the AND and OR expressions do you need to worry about. With the OR expression, we will short circuit on a true statement. On an AND, we will short circuit on a false statement. All right, that's the basis of what we'll be working with. We're going to work on a dice program called Craps, where you'll need to have a group of Boolean expressions or rational expressions, and then we will also do rock, paper, scissors. So there you go. Whoops.